Speech from Rainer Brehm, who's CEO of Factory Automation at Siemens. Please.
Yeah, so thanks for the invite. And well, we talk about turbulences in the supply chain. And my first slide, I think I didn't even know exactly what was the content here, but summarizes a lot of the things have been talked today in this forum. When you look about automation, in the past, you automated because you want to have a better cost position. You want to be more efficient. Or you automated because you could have a higher quality by automation, a faster time to market, or you want to have more flexibility. And that's still valid. You still do automation, you still strive in manufacturing for higher productivity. But what's new? Three new aspects. And we talked about that today. Sustainability. I strongly believe there is no sustainable future without electrification, automation, and digitalization. And in the forum before, in the panel, we discussed about purpose. I strongly believe that we can engage young talent working in industry, working in manufacturing, because we are one of the key enablers for a sustainable future. And we can do that by reducing resources needed. We can do that by reducing the CO2 carbon footprint. We can do that by moving manufacturing closer to the consumer. And we also get talent for that. And just to reflect on the last panel, I had people coming from Google, AI talents, and I was asking them, well, why you come to us? And we work using AI for optimizing processes, for example. And they said, well, if I work with Google, I'm using AI to put the best advertisement somewhere on a web page. If I work for Siemens or for an industrial company, I can optimize complete processes. I can reduce the energy consumption. I can get a better output. I can reduce the material used. So completely different purpose. And with that reason, we get really good people because this is a very diverse and very interesting thing where it can change the world. And I think there was one discussion on we should work on circular economy, on recycling. What I want to do, when we talked this morning about batteries and you need to recycle the batteries, what I want to do in the future, I want to repair batteries. I want to more recycle it. But I want to do the repair completely automated. So if we think about where we're going to apply our productivity or where we're going to apply our products, not only think about how you can recycle something, how you can repair something. And probably if you now go to Italy and say, I want to have a car battery because there will be a lot of batteries now in the market and they need to be somehow be reused, maybe in a second life or maybe again back in a car, you need to repair them. And you don't want to ship your battery then to Malaysia to get it repaired. You're probably going to repair it in Italy. Now, do you find people repairing it? And it's a high voltage, so it's also a risky thing. You can't put everybody on a battery. So why not doing it automatically? Automate battery repair. That cannot be done by a classical automation. You need to have very intelligent systems, leveraging AI, leveraging digital twins, in order to automated repair of batteries. Is that a purpose? Is that something I want to work for? Absolutely. So we have the use cases, we have the topics where we can attract people. Supply chain, the topic here, well, first of all, it's the topic of supply chain resilience, and I will come on that topic. It's very, very important. And I, by myself, also have 3 big factories globally, as I'm running the factory automation business at Siemens, 1 in China, 2 in Germany. I, by myself, we decided that we are decoupling. I had products only produced in China. I moved the product, for example, to Europe, and I'm currently considering why not building a new factory outside China, but serving the Asian market. Because the one topic is supply chain resilience, the other thing is the topic of decoupling. There is a certain decoupling. For sure, there will be globalization still going on, But we need to consider also geopolitical conflicts going forward, and therefore being more distributed, being more self-sustaining in certain areas definitely is, from a risk management, is necessary. And last but not least, the topic of lack of talents in an aging society. I mean, this was a discussion just recently, and we believe you need to automate more repetitive tasks. That is what you normally did with automation. But you also need to automate more tasks which are unique, which are non-predictable, which have a lot size 1, like repairing a battery is a lot size 1 topic, because every battery going to be different. The life cycle of every battery going to be different. So how can you automate maybe things which you couldn't be automating before? And with that, keeping the industrialization of the Western world upwards. If we don't do that, we don't have the people, number one. Number two, I think the other topic is how can we enable unskilled workers with human-centric automation, with a supportive system to bring them into the factories, to bring them in the workplace. Now, the one topic is you need to get a higher flexibility to do all that. And you need to walk away from kind of fixed line production. This was kind of Henry Ford. It was introducing, the conveyor belt. You need to go more and more into flexible and modular production lines. And I give you one example because we are in the Porsche Experience Center. So we did this. This is the Porsche. It's the Porsche Taycan manufacturing. I mean, you see some Taycans outside there. The first electrical Porsche. And Siemens did the complete manufacturing, the last line, and Porsche went away from a conveyor belt, used a lot of HEVs. It needs to be done in Zuffenhausen downtown, in two stores building. So we did all this automation, and Porsche said, I want to move away from regular conveyor belts. I want to have HEVs. I want to change the speed of production. I want to pull cars out in case something, I need to have a special treatment, a special color, a special interior. I want to move cars out if I see it's a defect. I don't want to repair the defect at the end of the line. I want to repair it directly, so I want to move it out. So a lot of flexibility was done here with Porsche on the Taycan manufacturing, which you see outside, one example. In order to do that, we talked also about that you need to get data, you need to get real-time data, and therefore we need to use much more IT technology, which are complex. I think this was the last panel discussion, but we need to make it usable in the manufacturing world, in the OT world. And we need to cover that complexity and make it accessible. Because in the future, we go away from you never change a running system, because that normally did. You switch it on and run, don't touch it, it runs. You will go away from that one, and you will have a continuous deployment of functionality to an OT system. In the software world, that's called DevOps, state of the art. In the OT world, I don't see a case where really a customer is deploying constantly new functionality to a shop floor. But we need to change that. And for that, we need to connect it, and we need to use the data much more, doing data analytics and based, because a lot of data are simply not used. So that is in the manufacturing. Now looking at the supply chain, I think also we need to connect much more supplier, manufacturer, and customers, having a quite holistic view. This morning we heard about activities like Gaia X. There is topics like Catena X. Manufacturing X is something coming up, connecting the supply chain. And I'll give you now 3 examples on that main topics, how we could do that. One is sustainability. We know that's a very important topic because manufacturing has 33% of the global energy consumption. Only a small part of the material really is recycled, and also has a big portion of the global CO2 emission. And Andreas, I think you talked this morning, so how now you get transparency, for example, on the CO2 emission on the complete supply chain. In my factory in Hamburg, we had the same question. So how we do this? Because our goal was we want to produce a CO2 neutral product. And then we have electronic manufacturing, we have pick and place, we do PCBs, we do soldering, blah, 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 like we do in electronic manufacturing. But we figured out that only 10% of the CO2 emission is done in our factory. The other 90% is in scope 3 and scope 2 of the supply chain. So the PCB board itself, the plastics for the housing, the components, the metals maybe on a heat sink, that is 90% of the CO2 emission. So we said, now if we optimize our production, we only optimize 10%. So how can we also, get the CO2 of our suppliers in? So that factory said, well, we need to do something. And you can do that with Excel spreadsheets, which will not work. And also, it's not audible. In the future, it needs to be audible. So we decided to put something in place, and this is now existing. It's called Seagreen, and it's based on open source. It's based on Estanium, which is an open network, where you can track the complete supply chain. So what you can do here, we can upload a bill of material, and we can request our suppliers that they send us not only the material, but send with the material the CO2 footprint of the material. And they can ask their supplier to send it. This is all based on latest web technology, some blockchain or verifiable credentials. So basically, it's a trustworthy way of getting data across the supply chain. So it's not somebody's collecting data, you do a peer-to-peer data exchange. So I get trustworthy data, kind of a blockchain element, from my supplier with the material. And if I assemble my product, I take this element from the blockchain and add it to the new blockchain, or to the new verified credential. And if I have my product ready, I ship my complete product to the next customer. In our case, a panel builder or a machine builder. So the machine builder builds now the product into the machine. And when they do building their machine, they also have CO2, and they add this to the blockchain. At the end, I can have for the machine, or you had the example of the car, for the entire car, the trustworthy, audible CO2 footprint. And I can only everybody invite to join that one. We don't want to earn money with this one. It's really also for free. And it's going to be part of Catena X, which is car industry, very relevant. And we also had a very big industry, the chemical industry, which is going to join forces on that aspect. And with that, we can have really transparency across the entire supply chain, from the raw material to the final product. And if that transparency in an automated way, not with Excel spreadsheets, then you can now start optimizing the logistic between it, optimizing the individual production process, or you can compensate maybe CO2 which was used. I think one very important example, which is a big pull current in the market. Secondly, supply chain. This was, in my business, the priority 0 over the last 18 months. 0. There was nothing more important than the supply chain topic, getting material out. And I just added one slide. This is an internal slide, which we put to our employees and say, and it was the discussion, it needs to be cross-functional. We need to have sales because they need to talk with the customer what we can do if we cannot deliver tomorrow, how we can mitigate the risk at our customer side. We need to have logistics involved. I will give you an example of that one. We need to have manufacturing and PLM, that is our R&D involved. And there, digitalization helped us. So we did more than 1,000 redesigns of our product. So our existing products probably are completely different than 18 months ago. And we're capable, in the meanwhile, when we found out by procurement that one part is not available anymore, we looked at the spot market, is there a comparable part there? And even it was a different supplier, we are in the meanwhile capable, if there's a compatible part, to change the part from supplier A to supplier B. In our product design, we can simulate the impact of that change. And if we see that impact is acceptable, we can, within 48 hours, put that change down to the production line. So a product design, product change down to a real impact on the production line within 48 hours. And with that, it made us much more resilient because we could look on the spot market where is material available and then feed it down. We also changed our production process, manufacturing. How we manufactured, normally we manufactured to stock. So basically look, what is the highest demand, and that we manufacture. We changed this now completely. We don't have this is normally you have a pull manufacturing. The stock pulls what you need. We changed it now to push because we look now what material we have, and according to what material we have, we produce. And we increase significantly the flexibility of our lines. Because if we cannot, because we need to run capacity 100%, whatever is, because we have so high demand, we could deliver everything anyway. So we changed completely our production process. So all this is working only in cross-functional teams and across the supply chain. I was this week, Monday, Tuesday, in Japan. And normally I go in these countries because I want to visit customers. I was visiting no customer in Japan. I was only visiting suppliers where we have a single source, because the one topic is you should not have single sources, but in some aspects you have single sources, especially if you use ASICs or very customized ICs. So I was talking with the CEO of that company to make sure they really understand the demand and they will be a reliable partner. Or we talk with other suppliers which we expect a huge increase from our demand, and they think that they can secure that supply. So it's a CEO job currently to make sure supply chain is running. And this is, so all functions are involved there. And one example, this is also an internal example, we have a complete digital twin of our supply chain. So we are tracking 11,000 suppliers on all our materials. So we know where in the world our material is. We're using external sources for that, and we get a real-time alert if something in the supply chain happened. So if a plane is delayed, or if a truck is in a traffic jam, or if something happened in the supply chain, we get this real-time data. We get an alert, and in the meanwhile, in 80% of the cases, we can act within 1 day. So we could call the supplier, hey, by the way, something stopped, what we do? Is there an alternative, what you believe? And with that, we had stopped fallouts by 40%, by that complete transparency on a supply chain. This is our internal example. Another topic was the lack of talent we have mentioned about. So the lack of talent is, we have a high risk of a deindustrialization if you don't find people who want to work in the factory. There will be a lot of jobs be open in 2030, and we need to figure out how we can work against that. One topic is getting people in, showing the purpose of manufacturing. This was a panel discussion before. The other thing is, can we automate more than we have automated today? And one example I was showing you on the battery manufacturer. Can we automate something which you couldn't automate before? And I show you now a real example. Siemens doesn't build robots, but there is a small gray box. This is a PLC, a controller. And in that controller, in that small box, there's a very sophisticated AI algorithm. And this is also what Ugo said in the last panel discussion. This is really, working with Berkeley, with university, what we teach this robot is not grasping something. This is possible. What this robot can do is, it has the skill to grasp something, the skill. So that robot get now a skill. That means, if I tell this robot now, grasp this thing, and I put it there, this robot will be capable of grasping the thing, even so it has never seen that thing before. Even so it was not trained by the digital twin of this product. That robot has never seen before that device and can grasp it. Why? It detects the device, he has the skill how to grasp, and with that I can automate something which I have not considered beforehand. And with that, grasping, think about Amazon fulfillment centers. How many people are there and taking something out of the box and put it into a new box? Tremendously. End-of-line consumer packaged good. Now there was Thanksgiving, probably, I don't know, Procter & Gamble had a special edition of Schaefer or whatever, and maybe this edition was only on the market for 1 week, so complete, you don't automate this. It's all manual work today. With that kind of technology, you can suddenly now automate this because you don't need to program the robot. And it's very easy because you can put it there. A lot of people are capable to program a PLC. You program a PLC and the skill, everything is inside, it's pre-trained. And then basically you can now want to grasp this one, you put it there, it grasps. So you go away from, you automate what is highly repetitive and known into you're going to automate in the future something which is non-repetitive and not known. And with that, you move from flexible and modular lines probably now more into an autonomous factory. Autonomous factory does not mean there are no people. There are still a lot of people, but the factory can react much more independently on changed circumstances. And I give you one example on that. The Porsche Taycan was still produced flexible because a huge HEV, but still the process was kind of pre-programmed. So, or if you want to change the car where it goes, somebody needs to interact. In the future, you might not do that anymore. And this is one example which we just bring in the market is you have 3 different products, and currently the utilization of the assets of the machine, you see on the other side the bar, is not optimized because normally you have a fixed way through the factory. In the future, this kind of boxes are machines and they have skills. And you have a product, and you might know that in the fantasies of Industry 4.0, you have a product with a bill of material and bill of process, and that product knows what it needs. And then basically the way of the product through the manufacturing is determined on real time. It's not pre-programmed. And you have AI algorithms on top who will navigate a product through a manufacturing site, through different machines having skills. And with that, you are much more flexible because if suddenly, for example, one machine stops, like now this machine stops or has an error, doesn't have material, or is on maintenance, the system now is in real time, okay, I don't go to this machine, I go to somewhere else. You make it more flexible. If you want to change the product you want to produce and you don't have the skills from a machine park, you not need to change a complete production line. You take out one of the machines or enhance it with a skill, and basically your factory is ready for a complete new product line. So skill-based automation with real-time capabilities going to be the future and be much more flexible to react on supply chain constraints. And with that, maybe in the future, it's possible that this small lady can build an individualized robot. So she dreams it. The father takes an iPad, takes a photograph, and you press buy. And maybe in the future then, a factory is capable to produce automated, a lot size one, scanning the required materials, putting a production schedule together, maybe 3D print parts of that unique robot, and then basically deliver it to the child. That might be a vision, and that might be a reality in 20 or 30 years, but the future is going there. Digitalization, the use of product design and realization, the use of new technology will lead the way to more and more autonomous operation. And that makes us much more resilient also in the supply chain. Thanks a lot.
Thank you, Rainer Brehm. Thank you, Siemens, for this vision of the future of manufacturing. Just a quick one, because For 2 days, we discussed at a global level, but at the end of the day, we are here in Italy. And what's your sense of where is the Italian manufacturing sector versus all these changes that you introduced today?
Well, I think on the spearhead. And I tell you why. You know, there was this big automation fair called SBS Fair in Nuremberg, and I think the nicest show element was coming from we had on our booth was coming from an Italian OEM. So applying AI, applying NVIDIA accelerator cards of doing a grasping application in the Italian machine. So it was, I think, the best application I had on this fair.
All right, that's good for the morale. Thank you again,
Thank you.
Ralph.